All right, hey guys, we are going to do lesson 11.3, which is solving quadratics by graphing. You're going to need the resource page or these pages from the substitute teacher, so make sure you grab those and are ready to go. So today we're going to be solving quadratics by graphing. Before we do that, we're just going to do a couple vocab words so we make sure we're all on the same page. So my word bank's over here, so if you guys can pause the video and try to match up these 4 vocab words with the words that match up. All right, so a quadratic, the word quadratic is any polynomial with an exponent of 2. So quadratics is just if it's a polynomial and there's an exponent of squared. So like y equals 5x squared, that's a quadratic. Y equals 3x squared plus 7. Y equals x squared plus 8x plus 10. Those are all quadratics. Parabola is the name given to the actual graph of a quadratic. So the parabola is the actual U-shaped curve. Okay, so we use that. Standard form, we have talked about this already. It's ax squared plus bx plus c. And then a solution, this will be new. You guys have talked about it before though, but a solution is a value that makes an equation true. So if I was solving like 2x equals 10, my solution is 5 because that makes the equation true. So today we're going to be solving quadratics, and we're going to be doing it a couple different methods, and one of them is by graphing. So that is method 1. So first thing I want to talk about, this will be kind of new, is when I have a quadratic, solutions are basically, if I kind of look at this, if I have a graph, the solutions to a quadratic are actually the same as the x-intercepts. So these are going to be my 2 solutions to a quadratic. They have a couple different names. One of them is called zeros. Now that kind of makes sense because think about this is when y equals 0. So those are called the zeros. Another name is it's called the roots, or roots, however you want to say it. And then I'm even going to put in parentheses, if I'm looking at a graph, it's the x-intercepts. So to solve a quadratic by graphing means to find where the graph crosses the x-axis. Okay, since we're on the x-axis, you guys can kind of see that there. It's when the y-coordinate is 0, right? Because this would be like 5, 0, 7, 0. All right, so we are going to be asked to solve an equation where we set it equal to 0. And you'll see what that means in a minute here. All right, if you go down to the bottom of the page, I'm going to give you example 1. So I have a graph for you, y equals x squared plus 6x. I already graphed it. Okay, so that's the graph for that equation. So it says, hey, look at that graph. What are the x-intercepts? Okay, well, my x-intercepts are pretty clear to see. They are -6 here and 0. So my 2 x-intercepts are -6, 0, and 0, 0. Okay, the solutions then, if I look at these 2 things, the solutions are actually going to be x equals -6 and x equals 0. Now, here's the point of this. You're not actually going to get an equation where it says y equals. We're going to have something where it looks like this. X squared plus 6x equals 0. And I'm going to be like, hey, can you solve that? Well, a way to solve it is to pretend where that y is, that that 0 is, that it's y equals x squared plus 6x. If you graph it then, which they did over here, the 2 x-intercepts or the roots or the zeros, that's going to be my solution to this equation. Now let's actually test it and see if that is the solution. So I can be like, okay, I think the answers are -6 and 0. Well, let's plug -6 in. -6 squared is 36, plus 6 times -6 is -36. Does that equal 0? It does. So one of my answers to this equation here is -6. We think the other one is 0. Well, let's plug in a 0. 0 squared plus 6 times 0, does that equal 0? Well, 0 plus 0 does equal 0. So these are my 2 solutions to this equation that I'm going to highlight in yellow here. A way to find those solutions is to think of it like the related graph and then solve it by graphing, because you'll get the same answer. All right, if you guys go to the next page, we have some key concepts with quadratics. So All quadratics have a different number of solutions. They can either have two solutions. You guys can see that there are two solutions here. They have two x-intercepts, or two zeros, or two roots, all the same names. They can also have one solution, okay, where it crosses just once. They have one x-intercept, one root, one solution, one zero. Or they can have no real solutions. It doesn't cross on the x-axis anywhere. So you might have an equation which is no solution. Just like if we had this, like x plus 1 equals x, hey, that's no solution. You're going to get some quadratic equations that don't have solutions. So if you guys scroll down, we have example 2. So we're going to try to use the graph of the quadratic to solve again. So here's my equation. It doesn't say y equals, but I'm going to actually graph, they already graphed it for you, the equation y equals x squared minus 2x plus 1. So they did the graph for you. So I know, hey, these two things are related to each other. They're going to have the same solutions. And then I'll just prove it to you. So, hey, if I'm looking at this, I see one x-intercept. Or again, another name is a root or a zero. It looks like it's just 1 comma 0. So I think my solution is going to be x equals 1 to the equation. Right? So I'm going to write that up here. Now I'm going to test it to see if it's right. So let's plug a 1 in here. So 1 squared minus 2 times 1 plus 1. That gives me 1 minus 2 plus 1, which is 0. So I know that is a solution to that equation. And I did it by using the graph. So let's go to example 2. On this one, it looks like there's no solution. Okay, I don't see any x-intercepts. All right, so that one has actually no solution. Not a way to test it at this point that we know of. All right, let's look at letter C. Again, they took this graph, they took this equation and they said, hey, think of it like this, as y equals, and then they graphed it down here. So if I'm looking, it looks like it crosses in two places. It looks like negative 4 is one solution and 0 is the other solution. Now I'm going to test it because I always want to see if that's correct. So let's plug in a 0 first. So my equation says 0 equals negative 0 squared plus 4 times 0. Okay, this is just 0. Plus 0 is 0. So 0 definitely works. Let's test negative 4. Now we have to be careful. So it says negative, parentheses, negative 4 squared plus 4 times negative 4. So if I do this, negative 4 squared is positive 16, but then it says make it negative, plus 4 times negative 4 is negative 16. Ooh. Okay, so negative 16 plus negative 16 is negative 32. Now, I know, like, hey, that's not right. So what happened? And I actually just had to pause the video myself and be like, what did I do wrong? Because that does not work there. So they actually, I got this was not my problem that I made, but they actually graphed that equation wrong. It should have been over here if they graphed it right. If I change this to a minus sign, now they have the right graph. So I just want to tell you the graph of that one was wrong to start with, so that's why. So just as an FYI, that graph should be, this. Let's just change it to minus 4x. Now this is the correct graph. Okay, then if I put that in there, so let's just do that here. Negative 16 minus negative 16, that does give me 0. So again, they had the wrong equation up here or the wrong graph, whichever way you want to think of it, just as an FYI. All right, let's try example 3 next. Okay, so now it says, hey, let's have you guys actually try one where you have to graph it. So now you have to solve this by graphing. All right, so if I look at this, I can already see, hey, this is pretty easy in standard form. My y-intercept is right here. It's negative 8, so I'm going to plug in a negative 8 here. Okay, I can also just graph that right away. Okay, next thing, I can do a couple different things. I can find my vertex. So I can say, hey, I can find my axis of symmetry by using negative b over 2a. Here's my a, my b, and my c. So negative b would be 2 over 2 times 1, which gives me 1. My vertex is 1 comma something. Okay, I'm even just going to draw in my line of symmetry real quick. So here's my line of symmetry. It's at 1 comma something. So let's plug in a 1. So 1 squared minus 2 times 1 minus 8. So 1 minus 2 minus 8 is negative 9. Okay, so my vertex is 1 comma negative 9. So let's plot that. That would be right here. And then I would have another point here. Okay, so I have that so far. If you guys look at that, so 2 is also negative 8. So then the next thing I would try if I were you guys is I'd be like, hey, can I factor this to find my x-intercepts? That'd be a little bit easier, right? Or you can just plug in numbers in the table. I'm going to try to factor it. So I know it's x and x. I think what times what is negative 8? But I can make a negative 2 out of it. Well, that looks like it's going to be negative 4 and positive 2. Okay. Now remember, to find the x-intercepts, it's what do you get when you make that equal 0. So it's going to be x equals 4 and x equals negative 2. So those should be my two x-intercepts. So my x-intercepts would be those two. If you weren't sure, you could now go back and plug in a 4. Okay, so I'll just plug in a 4 here. So I'm going to say, hey, 4 squared is 16. Minus 2 times 4 is 8. Minus 8 gets me to 0, so that's 0 as well. Okay, otherwise you could just kind of keep filling in the table. That's your other option. Now I have my parabola, or the related parabola. Okay, so this is actually y equals x squared minus 2x minus 8. So we know that the graph is going to relate to it. The zeros, or the x-intercept, should be my solutions. So I believe my solutions are 4, x equals 4, and x equals negative 2 are my two solutions to that equation up there. Again, let's check one. I'm just going to check the negative 2. So if I go back to the original equation, up here I just circled it. I've got 0 equals, I'm going to test negative 2. Negative 2 squared minus 2 times negative 2 minus 8. Well, that gives me 4 plus 4 minus 8, which is 0, so I know that is correct. All right, let's try example 4, and then I'm going to have you do example 5 on your own. So example 4, it did tell you to solve it by graphing, but it also says, hey, could you solve by factoring first? Okay, so we want to try to factor this. So this one might be a little harder to factor, but I still think we can do it. So if I factor it, I see it's a negative x squared, so it's probably going to be a negative x and a positive x. And then 5, there's only one, it's only 1 or 5. Okay, so I can put a 1 here and a 5 here, or I can do it opposite. And it's plus and plus, so I'm going to try plus and plus here. Okay, now I'm just going to check it to see if this works. Well, that gives me negative x squared. That gives me negative 5x and positive 1x. Ooh, that's a positive 4x. So I'm going to flip them then. Okay, so what if I put 1 here and 5 here? Wait, that's what I had, so never mind. What if I put 5 first and then 1 and test that? I'm just going to erase this. Okay, so I still get negative x squared, and then here's negative 1x, and here's positive 5x, which makes a 4x. So there we go. Now I have it factored. Okay, so lastly, let's just kind of see now. If I have that, I should be able to find my two x-intercepts pretty clearly. It should be, so I have to think, hey, what could I put in? So I have to think, what could I put in here that makes it equal 0? Well, a negative 1, oops, would make that part equal 0. And a 5 would make that, because it says negative x. So I think my two x-intercepts are 5 and negative 1. So here's negative 1, here's 5. I can also find my vertex. Okay, if I want to find that next, I can say, hey, it's negative b over 2a, or right in the middle of this, which you could find too, but negative 4 over 2 times negative 1. Right, here's my a, here's my b. I end up with positive 2, which is where I would think it would be. So it's 2 comma something. Then I can plug that in. I get negative, and then 2 squared plus 4 times 2 plus 5. That'd be negative 4 plus 8 plus 5. 4 plus 5 is 9. So 2 comma 9 is going to be that. Okay, now I can just graph my parabola. It looks like this. I could get a couple other points if I wanted to. But again, I'm really just looking for my solutions. So my two solutions are where it crosses at negative 1 and 5 are my two solutions for this one. Okay, so I should mention on this one, you can also get more points. Oops, didn't mean to move that. You can also get more points on this by just making a table. You have your vertex, you know, it was 2 comma 9. And then you could get the 1 and the 3, and kind of keep going from there to get a couple more points on the table. But we did find the solutions by graphing. All right, last one I want to look at is example 5, because this one's just kind of weird. I want to make sure I touch base on this one. And then we'll go through some of this on Monday too. But if you have an equation like this, okay, this is hard to solve by graphing unless we have it equal 0. So all I have to do is move this 12 to the other side. Now I have x squared minus 8x plus 12 equals 0. Now that's the equation I want to solve. That would make it a little bit easier. Now I can graph the related quadratic, which is y equals x squared minus 8x plus 12. Now I'm going to graph that. Okay, I know my y-intercept's 12, so I could start there. And then I just need to get some more points and then try to find the x-intercept. So you could be like, okay, I'm going to make a table. I know it's 0, 12. I'd find my vertex next, or I could try to factor it. Okay, so it's kind of your choice there to find the two solutions. So I want you to pause the video, try this one. When you're done, push play. All right, so my two solutions, if I factored it, I know some of you probably tried to factor it. Others of you made a table to find the x-intercepts. It looks like it was x and x and -6 and -2. Remember, x-intercepts have a y-coordinate of 0. So my two solutions, or roots, or x-intercepts, or zeros, another name for them, are 6 and 2. Okay, so my two x-intercepts are x equals 6, x equals 2. My parabola should look something like this. And there you go. You probably found the vertex too, which is awesome. Here would be another point across from here too. But my two solutions to the original equation are 6 and 2. You could plug it in. It should work. Let me just do a quick test. I know this video is getting long. I apologize. So 6 squared is 36. Minus 8 times 6 is 48. 36 minus 48 is -12. So I plugged it in this original problem. That worked. Again, I could plug in a 2. It will work as well. All right, so our goal for today was, can I solve quadratics by graphing? So hopefully you feel like you can do that. You're going to practice some problems now on the sheet that is attached to the rest of the problems, and then I will go over some of this on Monday. You may work with a partner on the practice problems as well.